On this episode of How Tech Works, take a ride down an Olympic-sized set of rapids that are entirely artificial, designed with cutting-edge skate park technology. And try this new suit on for size. You're going to need it for your next big trip to Mars. Hi there, I'm Basil Singer, and you are in for a thrill ride on this week's episode of How Tech Works. We're going to take a spin on a vehicle of the future. Here's a hint, it's got 2 wheels. And we're going to explore the underground tunnels of Barcelona without disturbing the peace above ground. But first, when you think of whitewater rapids, what comes to mind? Rafting in Colorado? The rivers of Zambia, maybe? Now, what if I said the English countryside? It's probably not top on your list, but there's a brand new artificial whitewater river in North London, and How Tech Works is going to be there to witness the wild water course get whipped into shape. Wow. Two years ago, this site was a car park. But thanks to the London Olympics, this stretch of whitewater takes centre stage.
We can create an alpine river in the middle of Hertfordshire.
With the heavy lifting complete, it's now up to these two to turn messy whitecaps into world-class rapids.
So what are we looking at then?
Simon Ricketts and Julian Gaspard know this stretch of riverbed better than anyone.
Over here, pour over.
They've spent months building, testing and tweaking every rapid along its length. Today, they've got their eyes set on one area in particular. This is the first big bend on the course. Block walls have already been added to constrict the flow, but the water moving through is still flat. It needs bigger drops, faster water and cleaner eddies.
So we're looking to add some blocks into the middle to create a feature both on this groin here and on this one here.
The trick? Fix one problem without causing 10 more.
A change can be made at one point in the course, and that affects both downstream of that change and upstream of the change. And then everything that you've worked on so far becomes null and void because the level changes so much that the features change completely.
To start, Simon heads to the centre's control room. Here, massive banks of computer equipment keep the entire system running smoothly, or stop it entirely. At the touch of a button, the pump stops and the entire river drains out. Now, the work crew go in. The artificial course here uses a special system called rapid blocks. Hollow plastic blocks that can be stacked like giant pieces of Lego and bolted into special rails in the riverbed. The blocks can be moved and angled in any way the guys see fit.
The trial and error has been, is it a single height, a double height, a treble height? How far we constrict it coming in at the sides? So what we're doing today is quite a subtle change with just a single block going in, and it'll be interesting to see how that changes from this morning.
They've got their fingers crossed that this simple fix will give the river the makeover it needs.
Right, here we go. Let's see how our changes have worked.
With the pumps turned on, the riverbed starts to fill back up. In a matter of minutes, the work area is buried beneath the waves.
So as you can see, the depth in the pool here behind me is much deeper. It's probably another 70 centimetres deeper. That's because these blocks here have backed the water up. The water's coming over those blocks and it's creating a bit of a V-stopper here. And then the 5 that we put across here has created a full drop, river wide, and now we've got a big hole with a stopper at the back of it.
Comparing the before and after at full flow, the change is obvious, but the guys have one more test. Upriver, Julian is preparing for action.
We always need to make sure the changes are safe and it actually works as we think it will when you're in a boat.
It's a big moment, but when you're testing 2 rapids at a time, it's also a very short one. In a few seconds, it's all over.
So how was that? Great, excellent.
This time, it gets the thumbs up.
Of course, we are happy when it works, but when it doesn't work, you learn.
Working with whitewater may be an art as much as a science, but the more these guys learn today, the closer they'll get to rapid perfection. From the north of London, we travel south, all the way to the south of Spain, in fact, to catch up with the European Space Agency's team of researchers. You see, the terrain at Spain's Rio Tinto region resembles our planetary neighbour, Mars. In other words, it's a perfect place to test the latest in Martian clothing. I'm a 38 regular, should anyone care to know. Human exploration on the red planet may be questionable, but that's not slowing down these researchers.
I honestly believe that the first human to walk on Mars is already born and is maybe right now watching Discovery Channel.
Getting to Mars requires at least a 34 million mile space ride, not a human-friendly feat yet. But scientists here say the terrain at Rio Tinto, Spain is as close as it gets.
There's spot here has kind of a magic because it's got so much potential to tell us about the way how things work on a totally different world called Mars.
Gernot Gromer is admittedly space-obsessed. As the president of the Austrian Space Forum, he spent the past 2 years piecing together 3,000 parts to create this one-of-a-kind Martian spacesuit.
It's also augmenting the capabilities of the astronaut. And that's a big difference to the current spacesuits because they don't need that.
Erlich Luger is a quasi-astronaut. For now, a suit tester, but Erlich still needs to meet all of the medical specs that the real guns do.
Every time I'm inside the suit, I'm very excited because there's always something new and something unexpected, and that's something which makes it really, really great. Something no one has done before.
It takes 4 hours and 3 people to fit Erlich for his tasks today. The 45-kilogram suit makes simply wearing it a workout. This suit is totally different than anything we've seen before.
If you would take a regular Apollo-type spacesuit like they used on the moon and put it on Mars, it would be dead and gone after a few days. And our suit is supposed to work for at least a year on Mars, because the next Radio Shack or a Home Depot, that's 380 million kilometers away.
With Superman qualities, the suit is designed to keep the astronaut alive in the harshest of conditions. The surface temperature on Mars is frigid, minus 113 degrees Celsius in winter, and the warm-up in summer isn't exactly sweltering. The hottest it gets is 0. So, the outer layer of the suit is made with stronger-than-steel Kevlar and an aluminium coating to keep it lightweight. Underneath, a wearable life support system.
At the moment, I'm very happy with the head-up display, which is working absolutely great. And I'm also receiving telemetry data, so I can have a look at my own status inside the suit.
This suit even has speech recognition and sensors to measure the physical performance of the astronaut.
I'm pretty excited for the first experiment.
One of today's tasks is maneuvering in the suit with a prototype rover, the Eurobot. Then, Urich has the finite task of taking soil samples so Gernot and his team can analyze contamination on the suit. They underestimate the dust.
The dust is the natural enemy of the astronaut, so to say. It's blocking mechanisms, it's covering the spacesuit, but the fine granular sizes of the sand here, it's everywhere in the equipment.
Just one of many discoveries made here. This suit simulator has wowed this crowd, but there's more work to be done to make it Mars ready.
And I'm sure people will be walking Mars, make no mistakes, this is a fact that will happen. I want to tell my grandchildren, you know, this little screw, that's the one I designed.
Welcome back to How Tech Works. I'm Basil Singer. We head now to Barcelona in Spain, where they're building a high-speed train line underground. This big dig poses many challenges for the engineers, starting with how the heck do you build a tunnel right underneath some of the city's most cherished historical sites without doing damage to the delicate buildings? The answer is right here. Barcelona is bursting at the seams with culture and street life. One of the big draws is architecture, like Gaudi's Sagrada Familia church. And this building, La Pedrera. A city this attractive means there are a lot of tourists and transportation needs. That's why they're building a high-speed train tunnel right through Barcelona, linking Spain to France. And we're taking you underground into the heart of things, where engineers are doing everything they can to protect the city above. José Gómez is responsible for risk control.
We're now at Sardinia Street, where the Sagrada Familia is located.
A short distance away, another icon.
We're situated below El Passeig de Gracia, one of the most famous streets in Barcelona. And to our left is La Pedrera, the second monument designed by Gaudi that our tunnel passes. As with La Sagrada Familia, our tunnel passes very close by.
The tunnel is 12 meters wide, running directly beside these buildings. That means the team is under intense scrutiny from media, government, even UNESCO, which protects the World Heritage Sites. Construction has been an exercise in extreme caution.
There's no room for human error here, no possibility for anything that could cause problems on the surface.
So far, they've carved 5 kilometers through the earth. They've got 200 meters more to go on this section of the line. This is how they're chewing through the earth with a tunnel boring machine, or TBM.
We're inside a tunnel boring machine designed to withstand ground pressure. These are some of the 18 motors. Between the cutting wheel and this chamber is where the excavated material is collected.
The machine is breaking new ground, not just under city streets, but under existing subway and rail lines.
This particular tunnel boring machine is for pressure-sensitive earth, more specifically for soil, not hard rock.
As the machine bores through the earth, there's a pressure difference between the leading edge, the cutting wheel, and this chamber, where the machine's course is set and monitored.
This is a dynamic project running 24 hours a day. Actions need to be immediate.
Pressure is highest at the front. That's why they hire diving experts to do maintenance on the cutting head. These are men trained, quite literally, in high-pressure situations. Today, the divers are changing bits on the cutting head.
Here, you can see the difference between a new cutting tool and a tool worn out by a very abrasive terrain.
Pressure sensors at the front of the cutting head monitor how much weight, pressure, and volume is being applied there. Jose and his team can track progress in real time on monitors, not just in the tunnel, but directly from their desks.
We see what the pilot is seeing. We have a multidisciplinary team with geologists, people who have expertise in risk control.
Engineers test for vibrations at ground level. Sensors at street level can detect shifts in the earth. So far, so good. The ground has subsided just 2 millimeters.
There's never before been a machine this big in Barcelona which has had so little impact on the surface. The street level changes are not only minimal, they guarantee to the people of Barcelona that there's been no damage to the structure of La Sagrada Familia.
The tunnel boring machine cuts through the last 200 meters and achieves breakthrough.
It's safe to say that the results have been even better than we'd hoped, and we aim to do it very well.
It looks like the buildings are safe, and the tunnel project is on track to bring more visitors to Barcelona. And finally, I thought I'd introduce to you something built for all you speed demons, but also for you backseat drivers. It might sound unusual, and it is, but this is a machine of the very near future that marries high-speed thrills on 2 wheels with extreme safety. Have a look. Sleekly designed with game-changing technology, this two-wheeled, fully enclosed electric vehicle is called the C1. Take a good look. If innovator Danny Kim has his way, the C1 will be just the revelation that upends the way we get around.
If you look at the real behavior patterns of commuters, you'll realize that 70% of most people drive alone. The average commute is 48 miles, and most people don't take more than just a briefcase or maybe a couple of bags of groceries.
Kim is founder and CEO of Lit Motors, a gutsy startup with a two-wheeled mandate.
So Lit Motors is a sustainable transportation company. We basically see that two-wheeled vehicles are the future of transportation for sustainability. Yeah, I like that. That's really
His
good.
goal? Give two-wheelers a makeover.
Let's get to a frontal view. No one's really innovating in the architecture of scooters or motorcycles. We can bring a lot of value and a lot of fun to sustainable transportation.
His small design and engineering team cut their teeth on this. A scooter that's cargo-friendly.
The cargo scooter is magic. It's the pickup truck for developing countries. You can put a 22 by 22-inch box inside.
This ride is fully electric and can hit 35 miles an hour.
Riding the scooter is great. It's like riding an electric stallion. That's probably the best way to describe it. Or unicorn, if you prefer.
But don't try this with your unicorn. Unicorns can't do this.
The folding's great. It loses 50% of its footprint. 50% of the scooter actually just kind of disappears into thin air.
Kim got even more ambitious with his next redesign, which is currently in development.
The C1 basically takes the efficiency and the romance of a motorcycle and combines it with the safety and comfort of a traditional car. It's going to be wicked fast. It's 120 miles per hour. This really handles like a car, and you sit in it like a car, you drive it like a car.
But what makes this two-wheeler truly exceptional is that it'll also be self-balancing. No need to put your feet down. And untippable, thanks to Lit Motors' patented gyroscopic-based technology.
The gyroscope dictates the tilt and lean of the vehicle at all times. So this vehicle could drift, which is really unprecedented for most motorcycles. In the case of an accident, the vehicle would skid rather than flip over, so it's exponentially safer.
Is an off-the-shelf electric scooter thing for kids that we retrofitted steering on, and then we're just taking advantage of the stock motor for driving it forwards and backwards. Sorry, it's classified. So inside the box is our core technology. It's inside a box because it's proprietary and we want to keep a hold on our secrets, but the basic concept is there's a gyro spinning a flywheel and a number of sensors to determine kind of what direction it's oriented, and we use that with a laptop to work on prototyping the balancing software and algorithms for keeping this thing upright.
Testing their technology under different conditions is crucial to perfecting it.
I would like to get up to 7. We'll have to play with that.
Today, they hit the ice.
Right now, we're going to see how it responds to side impact collisions from a safety standpoint. So we're out on the ice rink to simulate, like if you're in an icy and winter environment, if you get hit by something.
Cool.
Time to see if these conditions will impact their stability system. They start by testing its self-balancing feature.
I'm looking at a number of different things. I'm looking at what condition the battery is in, so I can see how it's reacting over time, how much power the flywheel's drawing, and then general information about the flywheel.
Despite the slippery surface, it performs well. Time to step things up.
Whew.
Will the scooter tip or glide on impact?
Here I go. It's holding up really well.
It's exactly what we expected it to do. We expected it to be able to hit and slide sideways as opposed to just falling over.
It glides, reinforcing what they already know. They're on to something pretty big.
For me, it's incredibly exciting. I've been working on this dreaming about this for the last 7 years. So being this close is pretty exciting.
I was just thinking about taking that non-tipping technology to the next level. No more training wheels on kids' bicycles. No more crashes at the racetrack. The possibilities are endless. Anyway, that's all the time we've got. Thank you very much for watching How Tech Works. Until the next one, I'm Basil Singer.